I'm here at Cornwood, near Plymouth, at our demonstration project. Plymouth is in Devon, in the UK, for any of those who don't know it. And I'd like to give you an overview of this demonstration project, which is now very close to completion as of the middle of April. So immediately to my left, we have our lower storage reservoir, which is currently being landscaped, as you can see behind this fencing. And as I move further forward, on the left, after the lower storage reservoir, is our powerhouse, and in front of the powerhouse is our main electrical intake. And I can see in front of me a temporary structure, which is where we're planning to mix our high density fluid, and that mixing operation is starting in the next couple of weeks or so. So to my left, we now have the powerhouse, and I'll give you a little bit of an explanation about how this project works. So within the powerhouse, we fundamentally have a pump and a turbine and a management system for the fluid. So what happens when energy is cheap and abundant, often produced by renewable energy such as wind or solar, that excess cheap energy is used to pump our high density fluid up this hill behind me. So it exits the powerhouse through into a pipe via a thrust block, where it turns up the hill to our top reservoir. This hill is 80 meters tall. And so we're using low-cost renewable energy to pump this fluid up the hill. And then as prices rise or energy becomes scarce, we release that same fluid back down through the same pipe, back into the powerhouse, where we regenerate electricity via a turbine. The round-trip efficiency of that action is around 80% in a commercial project. I'm at the centre of the operation of our high density hydro system. So immediate to me to my left here, under wrap, is our master control valve. So the fluid has flowed down through the hill, through the master control valve, and round the spiral casing of this Francis type architecture turbine. It flows round the spiral casing via the internal valves into the runner, and that's where we generate the electricity. So the runner is connected to the drive shaft, which goes out that side, and it goes via a torque transducer and a flexible coupling into the generator, where electricity is reproduced. It exits the runner in the centre here, down this large pipe to the bottom of our lower storage tank, which is beyond this wall here. And next, after showing you the turbine, we have the pump. So this works in reverse, so it takes electricity via its motor down the drive shaft, turning the pump impeller, and then the pump pumps the fluid again via a master control valve out of the building and then up the hill to the top of an 80-metre elevation. So you would think that this pump was big enough, but I can assure you that it is, even though it's a very small pump. Part of the reason why both the pump and the turbine are small is because with our high density fluid, everything gets volumetrically much smaller. So we're increasing the energy density. So this also means that the turbo machinery, such as the pump and the turbine itself, are much, much smaller. The next thing I'd like to show you in the powerhouse is our fluid sampling and management system. So what we have over here fixed to this wall are a series of holes in the wall connected to a sampling system. So what we can do here is continually sample and monitor the high density fluid, make sure it maintains the correct chemistry, the correct consistency. So this is monitoring the system, making sure optimum fluid health at all times. I'm now going to take you into our fluid mixing shed. Apologies for the noise behind me, but people are still working. So here we are, the fluid mixing shed. Please come on in. I'm now inside the temporary structure we have built for this project, which is where we mix our high density fluid. So this structure, everything you can see, we will take down and reuse on another future project. So what happens here is that we bring the raw ingredients in. So the main ingredient is water and our powder that we use. The powder in a large bag is loaded at the top here. The powder drops down through the hopper, is conveyed at the right rate into a wetting cone here. And then on the behind here, we have our chemistry and a water tank, and we use these pumps over here to control the speed of the water into the wetting cone, whereby the powder and the chemistry and the water are all mixed together at the right rate, and that is recirculated until we get the right density. It is then transferred at the end of the batch into an overnight storage tank, and then before putting it into the main lower reservoir, we check the chemistry again, and if need be, intervene and mix it to the right formulation and put it into the lower reservoir. We were just inside the fluid mixing shed, the temporary structure, and I brought you to the back of the building to show you a couple of the other elements. So immediately to my left is our daily store of water. So this is just potable water that we use to mix our fluid. And then beyond that we have two further tanks, which are volumes of our chemistry that we use for multiple batches of the fluid. The next part of our tour is to take you to the location where we store the mineral that creates our high density fluid. So here we are, and off I go. Please follow me. So as you can see, we have a fair amount wrapped outdoors to keep it dry until we're ready to use it. And then we have a shed here where we have a whole lot more, and I think the way in is through this door here. And here we are, a shed full of our mineral. Here we are, getting close to the top of the hill, walking up the route of our penstock, the pipe that goes from the lower reservoir behind me and the powerhouse behind me up towards the top of the hill. So this is an 80-metre hill. I've walked up here a number of times before, and I'm going to have to quickly jump this ditch, which is part of the water management of the project. So when it rains really hard, there's a ditch that can take the water away, stop it just flowing uncontrolled down the hill. So here we are towards the top of the hill. I'd like to just point out a few of the things that you can see from up here much more clearly. So we can see the lower reservoir, adjacent to it the powerhouse, just the corner of the main electrical intake, our fluid mixing shed all down there, and then our site cabins where we can make ourselves cups of tea if we need to. And then you can see the route of the pipe, the penstock coming up the hill, which is exactly what I'm standing on just as we get to the top of the hill. This landscape is a spoil heap from an operational mine, and so we're very grateful to the owners of the mine to allow us to use this as the location for our demonstration project here in Devon. So thank you, Sibelco. Here I am, having arrived to the top of our demonstration project hill. So this is an 80-metre hill, and I'm just quickly walking along to the location of our upper storage tank. If I turn around, as the wind has just dropped, so hopefully you can still hear me, to my rear is Plymouth Sound, a fantastic view from up here. And then in the other direction, we're on the edge of Dartmoor. So hopefully you can see that behind me. It's a really fantastic view from up here. So we are very lucky. And taking the last few steps towards our upper storage tank, past the control valve at the top, which is just to my right, and then up onto the plenum, or the location where the fluid gathers together before it heads down the pipe down the hill, and then into the powerhouse. So turning around quickly, what I have behind me is we have the 3 lengths of our upper reservoir storage tank. So what that means is we have 3 ends to the pipes with air inlet valves that you can hopefully see behind me, and then they're 60 meters long, and the other end of these pipes are 60 meters away, and hopefully you can see them in the distance behind me. I'm now just going to walk the length of our upper reservoir storage tanks, so hopefully Alex speeds this bit up because it will take me a minute or so. And we're on this very unusual lunar landscape. It should probably be the scene of some Star Wars film in the future, because you could imagine some droids passing along, going past. And so now you're behind me, you should be able to see these uprights behind me are the ends of the upper storage tanks. So these are 60 meter long, 2.5 meter diameter GRP pipes, which we store our fluid. So after it's been pumped up the hill, it's stored in this location until the energy is needed for consumers in a commercial project. Thank you.